Well, hello. Today we're going to become aerospace engineers. That means we are going to design something that actually slows down falling objects like parachutes and that are used in skydiving or space landings even. Like recently they had that space landing, the Artemis, that came back from space. I want you to think about for a minute, have you ever seen something falling really slowly on purpose before?
Yeah, like when people go skydiving in videos, or even when I drop like a tissue, it kind of floats sometimes. I saw people skydiving last weekend when I was at the pond.
Oh, that's a really good observation, Caitlin. Especially the tissue part. Why do you think a tissue doesn't fall like a rock? Or even with those people falling from the airplane, like you said at the farm last week, why don't they fall super fast and hard?
Well, for the tissue, it's really light and kind of spreads out, so the air kind of holds it up longer instead of letting it drop straight down. Also, the people have those big parachutes above them that acts like tissue. It does, right?
Yeah, exactly. Good job. You're already thinking like an engineer. Today, we're going to figure out why that happens. So, there's a force called air resistance. It's like a push of air against a falling object. The more air that hits an object, it slows its falls down. It slowers its fall, I should say. So, I'm going to show you something really quick. So do you see this piece of paper? See how it's flat right now? I'm going to crumble it up, just like this. And then I'm going to, let's move this out of the way. And I'm going to, right here, and drop it. Okay, did you observe that?
Yeah.
Now, I have this piece of paper. And it is flat. We're not going to wrinkle it. Now I'm going to put it up in the air. I'm going to have you observe it falling. Ready? Set, go. So, Caitlin, which one hit the floor first?
The crumpled piece of paper.
Yeah. Do you want to try it?
Sure.
Yeah, so let's try it out. Why do you think the crumbled piece of paper happened first?
Because the crumpled paper is smaller, so there's less air pushing against it, and the flat one spreads out more, and it just like floats down like a feather.
Yeah, that's a good observation, like the feather. The explanation is exactly what scientists say. Surface area matters. So, Kate, here's the question for you. If we wanted something to fall slower, would we want it spread out or would we want it more compact like our examples down here?
We want it more like open and spread out, and definitely not the compact.
Okay, I want you to go ahead and try yourself. Have the one crumbled, yep. And which one happened first?
Crumpled.
The crumpled hit the floor, and then which one took its time?
The open, non-crumpled one.
Yeah, good. Just like you observed before, and you use an example, just like the feather, how it just like slowly, peacefully falls down. And like you said last week when you were at the farm, you saw the skydivers. When you saw the skydivers, why were they not just dropping like that piece of paper did, that crumbled piece of paper?
Because the parachute was like open, and it like had there's a little pit inside it with fire in it, and it like adds air into the no, I'm talking about an air balloon. I'm talking about an air balloon.
Oh, the air balloon? How about the parachute?
Parachute is like, it's open, and as they fall, air gets caught under it. Like if I were to take a tissue, or like a paper, or like a plastic bag, and run around with it, the air get caught inside it. And
Yep.
if I just fell with it, the air would get caught inside it, and it would just fall slow down.
Yeah, I like how you said how the air get caught inside of it and it spreads it out, because that is true, and how it gradually falls down instead of just that straight compact that hits the floor super hard. So what we're going to do, Kate, is we're going to build a simple parachute. Engineers always start with a very basic design first before they improve it. So they always start small and then they build their way up. So what do you think is going to be the most important part of a parachute design that we're going to be designing today? What do you think that most important part is?
The size and the weight of the parachute, like the parachute itself. Size and the weight.
Oh yeah, the size and the weight, and also the top part. So that's a really, really good answer. I like that you use that. You're thinking about stability and surface area. So we're gonna build and see if your idea is right. So go ahead, take your materials and start building a parachute. I'll come over and help you. Just like that, you have the string and the surface area. Good job. All right, and then you're going to drop that. Good. I love that. All right. So as you built this, Kate, I want you to think a little bit more deeper. We started with that basic design that we observed together. What would you improve already if you had the time?
I already think the top might be too small. If it was bigger, I feel like it would fall slower because more air would be pushed against it and inside it.
Okay, so if it's bigger, so like with the parachutes, those people had at the farm, they were really big, right? And it was over them. So you're saying if we expanded it, because right now you have a small one, it would flow down slower?
Yeah.
Okay, so now we need to do a fair test. Same height, same drop, same everything, except the size of the parachute. Are you ready to do a bigger one?
Yep, there's...
All right. Let's do a bigger one with the same materials. And just do the string. Yeah, very good.
Yay.
Okay, now, ready? 3, 2, 1, drop.
That one kind of floated more than I expected. It didn't just drop, it kind of like drifted, you know?
Yeah, it kind of did. The drifting is a really interesting point that you came across. Why do you think it moved sideways instead of straight down?
Because the air wasn't perfectly even, so it pushed it around a little. Or maybe the strings weren't perfectly even, so it tilted.
That is true, especially because in the back of our classroom we have that air vent going, so there is a little bit of wind. So I really want to point out that you had a really good scientific observation. Uneven forces can affect the motion. So how long did it take for it to fall down?
About 2 to 3 seconds. It felt slower than just dropping the coin.
Yeah, it went really fast. So like, for example, we have this little bead right here, right? Imagine if I just dropped it. What do you think is going to happen?
It just goes straight down in like 1 to 2 seconds.
Ready, set, go. Oh, look at that.
It bounces.
It does bounce. Now let's try. What do you think is going to happen if I have a marker?
It just drops down. No
Yep,
more
drops
force.
down. There's nothing that's stopping it from going straight.
Gravity.
But, yep, the gravity. Good observation. We're gonna pause.
I'm hoping.
Okay, so Caitlin, before we move on today, I want you to explain this like a scientist. How would you explain this if you were a scientist?
Air resistance is when air pushes against the falling object and slows it down. The parachute slowed down because it had bigger surface area than the coin, so more air pushed against it.
Yeah. Now, I like how you said about the coin and how the air pushed against it. However, I have one more thinking question for you to get your brain moving even more. To get you to be more like a scientist. What would happen if we made the parachute twice as big? Because earlier we had to make it a little bit bigger, you said, to see if it would slow the dropping rate down. What would you think if I made it even bigger? Or even had you make it even bigger? What do you think would happen?
It would probably fall even slower because it would catch more air, but it might also spin if it was not more balanced.
That's excellent thinking. You're already predicting problems just like an engineer. So in today's lesson, you were able to explain how air resistance affects falling objects and describe how design affects speed. You were able to explain air resistance in your own words, build a simple parachute, and make a prediction using reasoning. And you were able to observe using evidence. Caitlin, how do you feel?
I feel good. This lesson was actually very helpful. I found it quite fun.
Good, I'm so glad. Thank you.